Okay, no need to type ID now. طيب. So let's continue with chapter 7 titled Kinetic Energy, and let me show you myself. So let's continue with chapter 7, and we stopped last time here. We need this example, we need to discuss it. It said, let me bring a pen here. It said, during a storm, a crate is like a box of a crib, is sliding across a slick, oily parking lot through a displacement d minus 3 I hat. What does it mean, d minus 3 I hat? Means it is 3 meters to the left. This is the displacement. Important to know. While a steady wind pushes against the crate with a force, this force. So I have this force. If you try to draw this force, 2 units I hat and 6 units j hat, means this is the force. Okay? The situation and coordinate are shown. How much work does this force do on the crate during the displacement? Well, and I know the law of the work. The work done by this force during this displacement is the following, is F dot D. So I have two laws. We said either we say F dot D or it is equal to what? Magnitude F, magnitude D, cosine the angle between them. Okay. But because I have I hat, J hat, I can directly do the dot product, F dot D. So F dot D, this is the force F, dotted product with the displacement minus 3 I hat, meter I hat. طيب now, well, how to do the dot product between two vectors? You multiply I hat by the I hat, a J hat by the J hat. Al I hat is 2, by minus 3 is what? Minus 6. طب والJ hat هنا minus 3, sorry, minus 6. On the D, how much is the J hat? 0. So minus 6 by 0 is 0. So it is what? Total minus 6 joules. The first conclusion, the work done by this force on the crate while doing this displacement is minus 6 joules. What does it mean? It means that this force is taking energy from the particle. It doesn't give him energy. It takes from his energy. It's like friction. It takes from his energy. Okay, so the particle is sliding to the left and the force is in the opposite direction. So try to slow him down, which is the steady force of the wind. So the fact that the work came negative, and we said work is a scalar quantity, can be 0, positive, negative. Negative means small. Scalar quantities, negative means small. Part B, if the crate has kinetic energy of 10 joule at the beginning, means K initial, okay? This crate has initial kinetic energy. What is the kinetic energy final, K final? Well, and I have the law that said total energy on a particle, here work kinetic energy theorem, is equal to delta K or K final minus K initial. And I have the work, I calculated the work to be what? Minus 6. Well, K initial is 10. Take it to the other side. It will be what? 10 minus 6 plus 4. So the K final is a plus 4, which means this wind slowed the object down, took from his energy, made it slower moving. Okay, this is good. Now we come to the topic of, نركز معايا هنا, lowering and raising objects. I hope everybody can see. Let me check that everybody can see. What is that? I want to be able to type. Okay, I think it should be fine. I think you guys can see me, I assume, right? Yes, we can. Okay, type. This is good. So I have this ball and I want to do two experiments. This is my hand and I want to raise the ball up. Raise it up. If I raise the ball up, what are the forces affecting the ball? The normal force of my hand which is up, and the weight force down. You agree with me? If I move the ball up, where is the direction of the displacement while I'm raising it? Positive. So the force done by my hand should be positive work or negative work by my hand. And my hand is the normal force. Is the work done by my hand should be positive or negative when I'm raising it up? الجميع, I need answers here in the chat panel. Positive. Why positive? Because the angle between displacement and the force is zero. Cosine is zero, is positive. But while doing this, what is the work done by the force of gravity down? The displacement is up and the force of gravity down. So what's the angle? 180. And what's cosine 180? Minus. So when I raise the object up, my hand, which is the applied force, the normal force, is doing positive work, while the gravitational force is doing negative work. Okay? Well, it's both of them equal, by the way, equal and opposite, equal in magnitude, but opposite, which means one is positive, the other one is negative. I cannot say direction because this is work. So in scalar quantity, I don't have direction. I'm saying only one quantity is positive, the other one is negative, which means the positive is big and negative is small. Right. Now, if I want to lower the object, where is the direction of the displacement? Down. صح? Now I'm holding the object, the ball like this, and I want to lower it. Its displacement is down. The work done by my hand in normal force, is it up or down? It's up. So what's the angle? 180. So my hand now is doing negative. My hand is doing negative work. How about the force of gravity, which is also down, is doing what? Positive work. Interesting. Why? Because the angle is zero. The angle is zero between the gravity and the direction of the displacement. So I hope you understand it. Now let's discuss it here. So in the first situation, the force of gravity here, this is the displacement up, the force of gravity down. So the angle is 180. That's the situation when raising the object. So when raising the object, the force of gravity, mg multiplied by the displacement, magnitude, cosine 180. So it's minus mgd. This is the work done by gravity when I'm raising the object up. The work done by gravity, when I'm lowering it down, it displacement down and force of gravity down. So it should be positive. So it is mgd, cosine is zero. So it is plus mgd. Now remember, my hand is doing opposite to that. So my hand here, or the normal force, is doing, if this is positive, here it's positive WA, applied force. And here it is minus WA. There is a relation. Remember the work kinetic energy theorem? It said work net. And what are the works net? Two forces doing work in any situation, either up or down. My hand, which is the normal force, and gravity. Means the work by my hand, اللي هي applied, plus the work of gravity equal to zero if I started stop and I stopped at top. يعني kinetic energy initial zero, kinetic energy final is zero. So it is okay. Delta K is equal to zero. As a result, it total works اللي هي from my hand and gravity summation should be zero. If the summation is equal to zero, it means that the work done by my hand is always negative the work done by gravity. Always negative to the work done by gravity. Opposite. That's why when raising the object, the work done by gravity was negative, but the work done by my hand was positive. And when lowering the object, falling the object down, the work done by gravity was positive, and the work done by my hand was negative. I want you to give a thought to this idea. Let me see. Let me see chat quickly. Yes, good. Right. Now, let's discuss a new topic, which is the spring. Now, I wish I have a spring. Do I have a spring? Okay. Now, say this is a spring, Zumbarak, okay? Spring. And I fix the spring, this is a wall. This is the same situation you have here. Now, if the spring is attached to the wall and it's not compressed and it's not stretched, I'm not trying to compress it, I'm not applying any force on it. What is the in the relaxed position of the spring, what is the displacement of the mass attached to the spring? Zero. So the force of the spring will not do anything. The spring, I'm talking about the force done by the spring. The spring will not try to do anything. It's just attached to a wall, from here a mass, but nobody tried to change anything on the spring. So the work done, or the force by the spring itself, is zero. Now imagine I will extend the spring. أسحبه لليمين كده. If I try to extend the spring will do a work. Where is the direction of the displacement when I try to extend the spring? شوف هنا. When I try to extend the spring, كان هنا الانيشال position. When I try to extend it, this is the direction of the displacement now. Right? Displacement, الإزاحة, the direction is into the right. Now, what will the spring try to do? The spring will try to return back. It's called restoring force. He's trying to go back to his original position. So where should be the direction of the force done by the spring? Left, opposite to the displacement. He's trying to go back. So the force done by the spring has to be in the opposite direction. Now let's try another thing. Here is the spring, and now I want to compress it. أضغطه. If I compress the spring, its displacement after compression is this, to the left, because I compress it, I decrease it. Now, what do you think the spring will try to do? The spring will try to resist a compression. So the force by the spring will be on the right side. Well, here we need to find something. The first thing is I notice that the displacement always opposite to the direction of the force by the spring. If I extend it, the spring force is to the left. If I compress it, the spring force is to the right, which means the force of the spring and the displacement, they are opposite in sign. So the law of the spring, the force done by the spring, is given as minus kd. Now, d depends on the displacement. How much is the displacement? And then this can vary. Yani displacement is not constant. I can make it 1 meter, I can make it 2 meters, I can make it 3 meters. Because of this, the spring force is a variable force. It's not a constant force. Nobody will ever say, find the force of a spring like this. He said, find the force of a spring if it was extended or displaced by 5 meters. Now you can calculate it because it's variable. It's not constant. It depends on the displacement. Another observation, it depends on this negative sign. It means always the force direction by the restoring force. وش معنى restoring بالعربي؟ قوة إرجاع الزنبرك. Yeah, Zumbarak tries to go back to his original position. That's why it's always opposite to the direction of the displacement. Clearly, the force by the spring, restoring force by the spring, is always opposite to the direction of the displacement. That's evident from the negative sign. And we need to describe what is this K. This K depends on the spring itself. This K is determined by the factory. When you buy a spring, it's written on it how much is the K. K is called the stiffness constant. The more is the K, which means if the K was 1,000, means this spring is not easy to extend and it's not easy to compress. It's very stiff, like the ones used in the cars. It's very stiff springs, very big, very thick, very strong. You cannot easily compress it. You cannot easily extend it. If the K constant or coefficient of stiffness was 1, then this is a spring that easily I can extend and I can easily compress. But the K doesn't change. El K is given from the factory. It's like the capacitor in electronics. It's written on it that the capacitance of this capacitor is this value, microfarad. I cannot change it. I bought it from the factory. So the K is constant, but the D is not constant. It changes with the situation. Type good. Now, if we have these conclusions about the spring force, we can talk about it. We can call it, give it a name. The force of the spring is called the restoring force, and sometimes they call it Hooke's law. هذا قانون الفورس of the spring. The restoring, أنا ما أتكلم على الفورس, ركز معايا. I'm not talking about the force done on the spring. I'm talking about the force done by the spring. قوة الزنبرك هو وش يعمل؟ The force done by the spring is called Hooke's law minus KD. It is a variable force, is not constant force. طبعا في واحد راح يقول لي طب ليه طلعت تقول constant و variable؟ تذكر ال constant force indicates constant acceleration. Constant acceleration indicates I can use equations of motion. but I cannot use equations of motion here. Why? Because the force is variable, means the acceleration will be variable. So I cannot use equations of motion with a spring. Okay? Another thing is the minus sign indicates that the D and the F always opposite. If the displacement was this way, the force of the spring will be this way. If the displacement was this way, the force of the spring will be to the left. A third thing, the spring constant K depends on the stiffness of the spring and can change with the spring. طيب. If it's along the x-axis, so easily I can say F will equal minus kx, force by the spring minus kx, because the displacement has to be along the x-axis. طيب. Now, what are the implications of a variable force? If I have a constant force, ركز معي هنا. لو كان عندي constant force, I can do the following. F dot D. هذا if I have a constant force. But I don't have constant force. I have variable force. And how to calculate a multiplication of a variable quantity? You do integration under the curve. So you do integration under the curve and you substitute a force. So it will become what? Integrate minus kx dx. طبعا this is from x initial to x final. طبعا, yeah. Initial position of the mass, final position of the mass. Now, if I try to do the integration of minus kx, I put the minus k outside. So هذه minus k. When you do integration, the constant comes out. The minus will k are constant. When you integrate the x, what is the integration of x? It's x square over 2. تعلمناها هذه. الآن I need to substitute the end points of the integration. So it is x initial to x final. والله بس في minus sign. When I solve it, it will give me this. This is the work done by the spring, not on the spring. Again, I'm talking about the force done by the spring, and I'm talking about the work done by the spring. I'm not talking about force done on the spring. I'm not talking about work done on the spring. So all of them by the spring. طيب. What does it mean? Means if I know the initial position and the final position of a spring, a mass attached to the spring, then I can find the work done by the spring. I can find the work done by the spring. What if the initial position was 0? If the initial position was 0 at the origin of the particle, then the work done by the spring will be negative. You agree with me? Yeah. If I extended certain x distance, because it's a square, it's not important if you extend it to the left or to the right, displacement. مش مهم لأنه it will be already square. But if the initial position was 0, the origin, the mass attached to the spring is located at 0, then if you extend it or you compress it, basically you're saying that the work done by the spring has to be negative if the initial position was 0. طيب. So here, if the initial position was 0, then the work done by the spring has to be negative. طيب. If now we talked about the work done by the spring, how about the work done by my hand? My hand is the applied force. It's similar to raising and lowering the ball. My hand is different than gravity. So we notice if the work done by the spring is negative, and work done by my hand has to be what? Positive, opposite direction. Opposite value. If it was minus 10 joule, the work done by the spring, the work done by my hand is positive 10 joule in case initial and final kinetic energies are 0. So the initial kinetic energy, so I start, أنا عندي spring and I compress it. I started from x equals 0, okay? And I compress it and I stop. So I started from stationary and I compress it and I stop. Means the initial kinetic energy and the final kinetic energy are 0. If the initial kinetic energy is 0 and the final kinetic energy is 0, معناه الwork net is 0. But I have two works. Work from my hand and the work by the spring. Work by my hand and the work by the spring. These two works, they have to be opposite in the value sign. So if one is minus 10 joule, the other one has to be plus 10 joule. طيب, this is good. This is good. I hope it's clear so far. You have a question, raise your hand. Let me see the chat panel. We want to go baby step. Why minus KD in the integrate? The integration minus KD because it's not a constant force, it's a variable force. And if I have a value that is variable, I cannot just multiply to find the work. I have to integrate. Why? Because it's changing value. شوف هذه مهمة جدا. خلينا أشرح لك إياها. Here. إذا أنت بتقول F dot D معناه انت شور انك الدي الاف دائما ثابته والدي دائما ثابته. But the force of the spring, this one, is always changing depending on the displacement. So I cannot say F dot D. I have to do integration because integration takes the variation. You took in calculus, you took what's called the Riemann sum, right? In the Riemann sum, if I try to find the area under the curve, I have to integrate over all these slices. So the integration, I take an area under the curve, so it varies, it's not constant. If it was constant, then the thing will be easy, like the area of this rectangle. طول بعرض, no need to do integration. But if it is varying with distance, then I cannot just do multiplication, I have to do integration, هذا calculus. Okay. So we talked about the force done by the spring. We said it's a variable force, so we have to do integration. But what if I have a general variable force, not necessarily a spring force? If someone said a variable, كيف تعرف ال variable force? A variable means it's variable in distance or variable in time. يعني كيف؟ لو أعطيك force أقول لك هذه الفورس 10 نيوتن. 10 نيوتن force. Is it variable or constant? يلا نشوف. على الشات بانل. A 10 نيوتن force, it is variable or constant? It should be constant. Man, I'm telling you it's 10 Newton. مش 9 and it will not be 11. I'm telling you it should be 10 Newton. No way it will change. But if I said, okay, thank you. If I said a force is 2x, it's variable. Because if I change the x, if I put 1x, it was 2 Newton. At 2x becomes 4 Newton. At 3x equals 6 Newton. So it's changing. If I said a force 10 Newton constant, if I said a force 10t, 10t means at t equals 0, it's 0. At t equal 1 is 10. At t equal 2 is 20. At t equal 3, 30 newtons, means it's variable. So a variation can be either spatially, distance, or temporally, which means time. Either I vary by distance or I vary by time. If my force doesn't have variation in distance or variation in time, so it means it's a constant, it's a number. So if I have a force, whether I change it in distance or in time, the way I find the work is by taking the area under the curve of what? Of force versus distance. هذه الarea under the curve represent the work done by this variable force. That's the meaning of the integration, which is the area under the curve. إذن هذا الانتجريشن of f dx is the area under the curve from x initial to x final. If I know the area under the curve, what does it represent? الwork. إذن هنا f versus x, الarea under the curve represent الwork. طيب خلينا أعطيك مثال هنا. Imagine I have a curve like this, then it becomes like this. هذا الكيرف، هذا الكيرف علمت عليه هنا. وهذا f وهذا x. Now, is this force variable or constant over the period? Is it variable or constant? Answer in the chat panel. It's variable, clearly it's changing. It's not constant, okay? It's not a straight line, it's changing. The area under the curve from here, from x equals 0 up to this x, is what? Positive or negative? اكتب لي الاريا اللي هي الورك هذا positive or negative? Positive. And it's the area under the curve. But the area under the curve from this point until this point is positive or negative? It's negative. It's below the curve. Similar to the idea of velocity and speed. In velocity, the area negative means it is negative velocity. negative direction. The speed, I have to take absolute value of the area because we said the speed, we're only interested about the actual distance crossed. يفهم علي؟ إذا الآن عندي مثال آخر. تخيل إنه أنا عندي هذه الفورس identical triangles. What is the network over the whole period from 0 until here? 0. Why? Because this work is positive and this work has to be what? Negative. اجمعهم لبعض. Positive area identical to a negative area. Network has to be 0. طبعا this axis has to be F versus LX. I hope it's clear. I hope it's clear. طيب. Anybody has a question يا شباب? Raise your hand if you have a question. We still have time. Raise your hand if you have a question. Anybody has a question? Raise your hand if you have a question. طيب. Okay, good. What? Let me see, there's a question. What about F versus Y axis? لا, إذا F versus Y axis means the variable force happens along the Y axis. It's okay, it's still work, but معناها الفورس either up or down. It's clear, يعني it's F versus X means the force either spring like this, but إذا عندي spring like this, yeah, معناها ال F versus Y. It's the same thing. Only I change the dimension, like fall. لا, falling objects, they're different. وش القوة اللي تأثر على falling objects؟ جاوبني على الشات. Yes. هل هذه constant ولا variable؟ جاوبني. لا يا أخي، ليه؟ mg, m is the mass with g 9.8. وش اللي فيها variable؟ disappointed. مين قال m is variable؟ الماس is variable؟ مين قال الام is variable؟ احمد خويهر. يا احمد الخويهر، كيف الماس is variable؟ لا انا ابغى احمد يجاوب. احمد، الماس is variable؟ change؟ الماس is changing؟ وقلنا الماس it doesn't change. If I take it to the moon or in space, it doesn't change. No, mass doesn't change. Mass of an object, it doesn't change. This object has certain mass. Well, weight doesn't change. مين اللي قال الويت change؟ الويت change if I leave planet Earth. If I go to the moon. On Earth, the weight is mg. We talk about Earth now. إذا الماss doesn't change. It's intrinsic property. G on Earth is 9.8. It's minus 9.8. So the force of gravity is a constant force. It's not variable force. Weight due to gravity, it is constant. And weight due to gravity is constant force, is not variable. If I talk about planet Earth, if I take it to the moon, maybe I have different thing, but on planet Earth is constant. حدا عنده خلاف هذا الكلام يسألني على الشات. أحمد الخويهر جاوبني. Do you understand؟ احمد خوير. ياس الحمد لله ممتاز. احنا ما شوف، احنا وير اوكي with اخطاء. انا احب الاخطاء تخليني اشرح. انا احب الاخطاء، ما عندي مشكله بالاخطاء. Nobody will offend anyone because of mistakes, but I want you to understand. Okay, طب this is good. Then we agree the force of gravity is a constant force. Why? Because it's mg, so it will not change. The force due to the spring is a variable force. Why? Because it depends on the displacement. As I move from one to another position, if the d changes, the f changes. So it's a variable force. طيب, good. No need to rush. نتعلم. طيب, now we come. So now if we said that the variable force, we need to do integration. Then what happens if I have a three-dimensional force and it's variable? If I have a three-dimensional force and it's variable, يعني عندي component I hat, and I have component of the force j hat, and I have component of the force k hat, then I have to do over each dimension an integration. يعني لو كانت الفورس الcomponent of the x مع dx على limits x initial x final, and I have fy مع dy y initial y final والfz مع dz from z initial z final, I treat everyone independently, then I add the numbers because this is work. الx يعني if I may call it, وهذا الwork الy, I just add it. الwork is a scalar quantity. This is work z. It's not vector, it's a scalar quantity. So I can add it just as numbers. I have example on this idea. Here's the next example. This example. So this example said, if you have a force 3x squared plus 4n j hat. سؤال للجميع على الشات. Is this force constant or variable? Yes, of course variable. الجميع لازم يعرف انها variable. Why? لانه في عندي x variable. It's not a number. لكن حسألك ال y component of that force, is it constant or variable? ال y component is a constant. Al x component is a variable. As a result, what should be the force? Variable. واحدة تخرب. ال y component is 4 Newton, constant. Al x component 3x squared, variable. As a result, when I add them together, what should be the force as a whole? Variable. He said even one will destroy it. Will disturb it. Will make it variable. Even one component. Very good. Then I have to use integration for this example because it's a variable force. Force F, 3x squared I hat Newton, or 4 Newton J hat, where x in meters acts on a particle changing only the kinetic energy of the particle. How much work is done on the particle as it moves from x initial, y initial to x final, y final. يعني ال x initial to x final هذه وال y initial to y final هذه. Does the speed of the particle increase, decrease, or to remain the same? In order to know if I need to find the work, I need to fx component هذه fx dx. طبعا what's the x values from 2 to 3 هاي from 2 to 3. y, what's the y component of the force? Only 4. It's not variable, it's constant. 4 from 3 y initial 3 to 0. So from 3 to 0 dy. كيف تعمل integration? A 3x square integration is x cube over 3. Then you substitute the limits اللي هو 3 with 2. First 3 minus 2. When you substitute it, you get this. Al 4, what's the integration of 4 dy? It's 4y. Substitute when 0, it's 0. Substitute when it's 3, minus 3. الجميع. أنا أبغى أسأل هنا على الشات. Who has a problem doing integration? مين ما يعرف يعمل integration of a polynomial? Easy. لا حدا tell me I don't know. Hard ones. Integration. صعبة. Okay, we can extend the example here. إذا إنها صعبة, and I will extend the example. يلا integrate هذه 3x square حنعملها سوا. 3x square from 2 initial to 3 dx. وش أعمل؟ قلنا الكونستانت بيطلع برا، هذه الثلاثة بتطلع برا. Integration of the polynomial x square, we increase the power by 1, so it becomes x cube. We divide by the new power, which is cube. هذه الثلاثة cancels مع الثلاثة. الآن عندي limits from 2 to 3. I need first to substitute at 3, which is what? 3 cube minus 2 cube. يعني I start with the upper limit minus substitute the lower limit. 3 cube كم؟ 27 minus 8 صح؟ 2 cube 3 cube 3 2 cube 2 by 2 by 2. So it's equal to what? 21. إذا ال x component 21. خلينا نعمل ال y component. Integration of 4 dy من كم لكم؟ من 3 إلى 0. شو يكون integration؟ 4 y. لأنه integration of dy is y. One power is 1. So here y هنا الباور كان 0, increase 1 becomes y. Power is 1. كانت 0 صارت 1. Now from 0 to 3 هنا 3. Substitute first is 0. كم تصير؟ 0. Minus substitute 3 إذا كم تصير؟ 12. 21 و 12 كم يطلع؟ هاي كم؟ 21 ولا احنا made a mistake؟ Do I make mistake? We made a mistake. Did we make a mistake? 2 to 3. What؟ لازم يطلع معنا 7 جول. ليه كده؟ 7 جول 7 جول 7. في حاجة نسيناها؟ في حاجة نسيناها؟ الله. What is this? في نسيت حاجة؟ 19 not it. Oh I'm sorry, it's 19. Yes, sorry. I thought it's 29. So this is 19. 19 minus 12 is 7. Thank you very much. So network is equal to 7 joule. Now, if the network was plus 7, do you think the speed of the particle increased or decreased? احنا قلنا الwork kinetic energy said الwork equal delta K. So if the work came to be positive, means the K final was greater than the K initial, means the speed of the particle increased. The speed of the particle here increased, not decreased. Why? Because the work was positive. Well, K final means it's greater than the K initial, so the speed of the particle increased. Let me see the time. Okay, we still have time. طيب, okay, good. طيب, let me see in the chat. Everything is clear يا شباب? طيب, good. Anybody has a question so far? Raise your hand if you have a question. ما بدنا عجلة, بدنا نفهم. طيب, good. Okay. Now we come to the topic in the last 5 minutes of the power. Remember, the power, we know that the power unit should be in watts. When we buy something called power is what? What is the watt? الوات أو الباور is defined as energy or work per time. إذن الباور is abbreviated as B, is defined as work over time. الunit of the work is joule, والunit of the time is second. So 1 joule 1 second is equal to 1 watt. هذا الunit of the power is the watt. What does it mean الwatt? It means how much energy I can transfer to the particle or take it from the particle in a unit of time. وانت لما when you buy a car and he said this car has 1,000 watts power, what does it mean? It means this car can give me 1,000 joules in 1 second. That means 1,000 watts. So this car, this machine, can give me 1,000 joule in 1 second. That's 1,000 watt. Okay? الآن, work is a scalar quantity. What time is a scalar quantity. So the watt or the power has to be what? Is a scalar quantity. Okay? So it's defined as the time rate at which a force does work, which means the variation of the work with time. If I divide the work or the energy delivered by time, then I will find الwork. The unit of work is what? And there is an example. When you receive the electricity bill, يقول لك electricity bill is said kilowatt ساعة. ليش يسموها kilowatt ساعة? Do the cross product here multiply. معناها الwork كم يساوي؟ الwork equals what? B في T, right? لما تقول كيلووات ساعة انت وش تدفع الالكتريسيتي؟ تدفع انرجي work. والبل اللي تجيك هذه الغريبه كيلو وات multiplied by ساعه, it means الكيلو وات is power multiplied by time is what? Is the work. So what you pay is the energy that you consumed from the electricity line. Okay, so this is an example that the electricity bill is basically energy because it's power multiplied by time. طبعا I have two definitions of the power. I have B average power, which means delta work or work over delta T, which means I take it over a period. What does it mean? احنا الافريج وإحنا عارفين وش meaning of the period. Average means I take it over a range, a period, not at certain moment. So I have B average. Well, B average is work over delta T. لكن I have also instantaneous power, which means if I have a work as a function of time, and I derive and substitute at certain time, I can find what? Instantaneous power. Then I have average power, which means work over delta T, and I have instantaneous power, d work by dt. In both, the unit is the same, is the watts, is joule divided by second. One other law for the power is this. The power for a force making the object going in a certain velocity is F dot V. يعني if I have, it's instantaneous also. Then instantaneous, I have two laws. D work by dt or this law, F dot V. هذا means if there is a work, if there is a force causing a particle to move in a certain velocity, a dot product between the force والvelocity will give me what? Will give me the power. طب what happens if the velocity and the force perpendicular to each other? If the velocity of the particle, يعني particle moving this way, will force affecting him this way, what does it mean that the power done by this force? Zero. Why? The angle is 90 and cosine in 90 اللي هي بالdot product will be zero. Let's take an example. A block moves with a uniform circular motion. تتذكر اليونيفورم circular motion هذا الدايركشن للسنتريبيتال فورس، لكن where is the direction للفيلوسيتي؟ either up or down، لانه احنا قلنا tangential. In any case, if it's clockwise or counterclockwise, the angle has to be with the force, centripetal force, what? 90. إذا الباور done in a uniform circular motion by the centripetal force should be what? Zero. So, the work done, the power done by a force in a uniform circular motion should be zero, because always the direction of the centripetal force toward the center, or always the direction of the velocity is tangential, so always making a 90 degrees. So always the power done by a centripetal force is equal to zero. I want you to give a thought to this and understand it. Inshallah, next time we continue. Let me see the chat panel before I let you go. Yes, good. Is it clear يا شباب؟ الأمور طيبة؟ نبغى دراسة، الامتحان قرب الميد تيرم وعليه بتحدد كثير حاجات. كل حاجة أعطتك إياها coming soon. أنت you think it's far, it's coming soon. ما عندنا وقت. So you need to review everything. All the questions I gave you, all the recitations, all the examples, you have to study. And inshallah, we stop here. We exceed the time. Assalamu alaikum. See you on Sunday.